Here's the word problems that we talked about in class today. I know they're pretty hard, so I thought it might help to have a video so that you can study up on these a little bit before the quiz on Friday. The first problem, the rowing problem, we had one guy rowing on a lake and one guy rowing on a river, and we have to consider the distance, the rate, and the time, because we're going to use the formula distance equals rate times time. So sometimes it helps to set up a table like this just to keep everything organized. You don't have to do it this way, but it might be helpful. Alright, so what's going on here? They both row 4 miles. Okay, so distance is going to be 4 in both cases. However, on the river, it might be smart to break it up to 2 and 2, because on the river, you first go 2 miles upstream and then you go 2 miles downstream. And when you're going upstream, well, okay, back to the lake. Let's see, we want to know how fast is the lake rower rowing. So maybe we should make our variable the speed of the lake rower. And if x is the speed this guy rows, then when he is going upstream with the 3 mile per hour current, his speed would be x minus 3. And when you're going downstream, you're going x plus 3. You're going 3 miles per hour faster than how fast you normally row. So what we need to figure out is how much time it takes this guy and how much time it takes this guy. And we can do that using this formula right here. Since distance equals rate times time, we could solve this for time for t. Divide both sides by r and get that time is equal to distance divided by rate. And so since we have distance and rate, we can figure out time. Distance is 4, rate is x, time is 4 divided by x. Down here, distance is 2, rate is x minus 3. So for the upstream portion, the amount of time it would take is 2 over x minus 3. And then we want to add to that the amount of time it takes to go downstream. Again, you're going 2 miles, but now your speed is x plus 3. And so once you get time, we can kind of put everything together using this fact right here. It takes the river rower 50% longer. That is maybe the time on the lake times 1.5 is going to be equal to the time on the river. If you're not sure which side to put this 1.5 on, you think about it like this. It takes the river rower 50% longer. So the river rower, this thing over here should be bigger. So we're going to multiply this by a number bigger than 1. We'll make it bigger. So that's saying this right here is bigger than this right here. So anyways, 1.5, maybe we'll call it 3/2. Time on the lake is 4 over x. And the time on the river is 2 over x minus 3 plus 2 over x plus 3. Right, I'm just pulling all that information out of this column right here. And 3/2 times 4 over x is 12 over 2x, which is the same as just 6x. 6 over x. Sorry. 6 over x. And now, let's see, to make this a little bit smaller, you could divide both sides of the equation by 2, change this to a 3, this to a 1, and this to a 1. But I don't think we did that in class today. I think we just went ahead and solved it, so I'll go ahead without doing that. Multiply both sides of the equation by the least common denominator. The least common denominator is x times x minus 3 times x plus 3. When you multiply this over here, the x's will cancel, and you'll get 6 times x plus 3 times x minus 3. And if you multiply this term here by the least common denominator, the x minus 3's will cancel, and we'll get 2 times x plus 3. And then finally, if you do that over here, the x plus 3's will cancel, and we'll get 2x and x minus 3. And so if you get to here, you did really well in this problem because it's pretty hard, but from here it's not as bad. It's solving, it's a 1 point, it's the previous section, whatever number that was, problem. It's just an algebraic expression that we got to solve. I guess it kind of turned into that problem at this step, but even at this step it's kind of hard because it's still fractions. But here all we got to do is combine like terms and then solve for the x. So over here we got x plus 3 times x minus 3 is x squared minus 9. But if you distribute the 6 through, you get 6x squared minus 6 times 9 is 54. And on this side, 2 times x is 2x. Distribute that through, and you get 2x squared, 2 times x, plus 2 times x times 3 is 6x. 2 times x is another 2x squared. 2 times x times negative 3 is minus 6x. Let's see, this is kind of nice because we have a positive 6x and a minus 6x, so we can just cancel those two guys out. And then if we combine like terms, let's see, we have 4x squared over here and 6x squared over here. So let's subtract 4x squared from both sides, and we'll get 2x squared. And if you add 54 to both sides, you get is equal to 54. So to finish up, divide by 2, take the square root. Really, we should put a plus or minus here, but since x is the speed that you're rowing on the lake, we don't want negative, we want speed to be positive. So we'll just take x equals root 27 as our answer. And finally, that's the end of this first word problem. The second word problem, a little bit quicker. I don't know if it's any easier. It's the fence painting problem. And the idea is it takes me 20 hours to paint the fence and it takes somebody else 15 hours to paint the fence. And we want to know how long it would take if we work together. And sort of the trick on this is to add maybe our painting speeds. And what I mean by that is we'll again use our distance equals rate times time formula, even though it doesn't seem to apply here. And we'll let our distance be kind of our goal, which is the one fence we want to paint. And then our rate will be kind of the speed at which we're painting these fences. So since it takes me 20 hours to paint a fence, we could say my speed is equal to, I do 1/20th of a fence per hour, and my friend's speed, see, it takes him 15 hours to paint the fence, so he does 1/15th of a fence per hour. And now we have our two speeds, so if we work together, the combined speed will be this plus this. So combined speed is 1/20th plus 1/15th. It's a little hard to add up in your head, but you could think of 1/20th as 1 divided by 5 times 4, and 1/15th as 1 divided by 5 times 3, and then figure out what we got to do to get a common denominator. Let's see, over here it looks like we're missing a 3, so we'll multiply by 3 over 3. And over here we're missing a 4, so we'll multiply by 4 over 4. And if you do that, you get a common denominator of 3 times 5 times 4. 15 times 4 is 60. And up top we got a 3 plus a 4 is 7. So we got our combined speed is 7/60ths. So what that's saying is that we paint 7/60ths of a fence per hour. So if you paint 7/60ths of a fence per hour, and you want to paint one fence, the time it takes will be 60 divided by 7. If you have trouble going from here to here, what you can do is say, all right, time is equal to, solving this equation for time, it's equal to distance divided by rate. So we got our distance, remember we said was one fence, and our rate is what we figured out here, this 7/60ths. So this is 1 over 1 divided by 7 over 60. Dividing fractions, you flip the you flip the denominator upside down and multiply. So flip this upside down, multiply by 1 over 1, and you get this 60 over 7. What's that, a little more than 8? 8 and 4/7 hours, I guess, is the time it ends up taking. But you can just leave it as a fraction like this, and that's the answer and the end of the word problems.